Hi everyone, welcome to Star Grade Chemistry. So in today's video, we will practice some really important organic chemistry questions for your MCQ paper IGCSE level. These MCQ questions will be really helpful for you. They have such concepts which are being repeated in most of the PYQs question, and you will never feel stuck if you practice these questions, I'm sure. So let's start with the first question. So the flowchart shows how petroleum may be turned into plastic. So there are three processes which examiner want to ask. First is petroleum to saturated hydrocarbon, to unsaturated hydrocarbon, and then finally to plastic. So let's look at the first process. Petroleum to saturated hydrocarbon. If you remember, there is this big diagram given in your Cambridge Chemistry press book. So petroleum to saturated hydrocarbon is your fractional distillation. Fractional distillation. So in this process, what happens is that we have this huge chamber. Petroleum is entered from here, also called as crude oil, as mentioned in the diagram. So according to the difference in boiling points, this crude oil gets separated into various components like petrol, diesel, naphtha, bitumen, and their uses are also given in the book, right? So remember, petroleum to saturated hydrocarbon is your fractional distillation, right? Second process, saturated hydrocarbon to unsaturated hydrocarbon. This is again one of the most important concept and it gets repeated again and again. Even in the theory paper, it has been asked many a times. So this process is your cracking. The best method to remember the process's name and identify them is to remember the initial point and the final end point, right? So saturated hydrocarbons to unsaturated hydrocarbons, that is your alkanes being converted to alkenes is via cracking. There is this very important reaction also given in your book. Decane converts to octane plus ethene. As you can clearly see, first we had saturated hydrocarbon, alkane, and now we have alkene here, ethene. So clearly this process, catalytic cracking to be very precise, this process, remember, alkanes to alkenes is via cracking. Now when you have alkene, for example, let's take smallest alkene, ethene. And we know plastic is a polymer, right? Like polyethylene, very commonly used polyethylene. So from one molecule to many number of molecules being stacked together is known as polymerization, right? So alkenes to plastic, that is to polymer, is your polymerization. So finally, third process we have is polymerization. Answer will be C option. So what did we do? We first converted petroleum to alkanes, right? We separated one component, and then this huge component is being converted to small alkenes. And again, this alkene is polymerizing into a big polymer, polyethylene, which we commonly use as plastic, right? So this question had three major important reactions or processes. Hope it is very much clear. Next. For students having course 0620, this concept of esterification is very important and we will quickly do it with the help of a trick, right? So what is ester, right? This question is all around ester. So we'll first look at what is ester. It's a fruity smelling, sweet smelling compound formed when carboxylic acid reacts with alcohol to form ester and water. Now this process is known as esterification, formation of ester by carboxylic acid and alcohol. Ester looks something like this. It has this C double bond O, O group and carbons attached here. Let's suppose I have one carbon here and one carbon here. This is one example of an ester, right? So what we will do is that we have to think backwards. The ester is given and we have to identify from which carboxylic acid, which alcohol it has been derived. So what we will do is that make a cut. Make a cut right here. You have the answer, right? When you make the cut, this portion where you have single bonded oxygen atom, single bonded, this is derived from your alcohol part, and the portion where we have C double bond O, this portion has been derived from acid part. So if you look at this ester, this is the same thing only. We have put a cut. This is from alcohol portion. Now this contains one carbon. So the alcohol must have been methanol. Meth means one carbon. The second half, which is having double bond O, has two carbons. So acid of two carbons is your ethanoic acid. So this is sorted, right? So by just looking at the ester, we can cut it into halves. We will clearly have the alcohol portion and acid portion. Now next question comes of naming of this ester, right? So how will you name this ester? Again, very simple. First, name the alcohol part. Alcohol part like this. So this has one carbon, so you will write methyl, okay? And the acid part contains two carbons, so you will write ethane, and the suffix of ester is OAT. Suffix tells you about the functional group, like ethanoic acid, oic acid is the suffix, methanol, all is your suffix. So similarly for esters we have OAT, right? So methyl ethanoate. So answer will be your methyl ethanoate, ethanoic acid and methanol. This one, right? We can quickly have one more example. Suppose we have this ester, right? Now this is an ester because it has this group. Okay. Now to follow the trick, simply cut it from here. Write this portion first. It has two carbon, so write ethyl. Okay. This portion has one carbon, so methane, and OAT is the suffix. So ethyl methanoate is your ester. All right. I hope this is clear. So we have discussed the ester concept completely. We have discussed how to identify which carboxylic acid, which alcohol is forming the ester, and the ester formed, we can also name that ester by using this trick, right? So let's move on to the next question. Yes. Methane reacts with chlorine in substitution reaction. Now this again is a very important topic. Substitution reaction. Substitution simply means what? Replacement. Okay. So how many products containing a single carbon atom can be made during the reactions? I'll quickly make you understand this reaction. Very simple, easy trick. Methane is CH4 and you add chlorine. This reaction takes place in the presence of UV light. So I'll just write UV light. Okay. Now what you have to do is that you have to replace one hydrogen and remove one chlorine from here. You will get HCl. Whatever is left, make the product. CH3Cl. So one hydrogen, this had four hydrogen atoms. One hydrogen is replaced by chlorine atom. Okay. There were two chlorine atoms. So one chlorine atom is placed here. Another chlorine atom is bonded with the hydrogen which was displaced as HCl. Now this process can keep on going. Again, if you add Cl2, Now suppose this hydrogen is replaced. You will have CH2Cl2 left, and the hydrogen which is replaced gets bonded with another chlorine atom to form HCl. Okay, so and so you will get again one hydrogen replaced, CHCl3, again one hydrogen replaced, CCl4. So it is very simple. In CH4, first you remove one hydrogen and replace with chlorine, CH3Cl. Replace one more hydrogen with chlorine. So now three hydrogens were there. Now you are left with two hydrogens after replacing. So CH2Cl2. Again remove one hydrogen and add chlorine. So hydrogen is decreasing and chlorine is increasing, right? So CCl4. So how many products containing carbon? You don't have to count HCl here because it does not have any carbon. So 1, 2, 3, 4. Answer will be 4. Okay, very simple. Cambridge genuinely tests how well you read the questions. It is very important to read the question, underline the question while you are reading, and then answer the question. Okay, let's move to the next question. The diagram shows structure of polymer. Again, there is this question of polymer. Okay, this type of questions are very common, and you must have seen these type of questions in previous year questions also. I'll just zoom in to the polymer. Okay, think it like a game. This is the polymer. You have to identify which is the smallest repeating unit, okay, which is being stacked again and again to form a polymer. Okay, so minimum repeating unit should have at least two carbon. Minimum. I'll tell you why. So we can see this here, right here, that this segment is being repeated. In this segment, there are two carbons. One has CH3, another has C double bond OH. Okay, it has been repeated here. The pattern does not matter. There are two carbons. One has CH3 group, another has C double bond OH. Then again, two carbons. One has CH3 group and another has C double bond OH. So our repeating unit is this. CH3, H, C, H, C double bond O, H. This is our repeating unit. Now a very simple trick. When you are satisfied with your repeating unit, just simply close the side flaps to one double bond. So the monomer will be, just remove these bonds and add a double bond here. H, H and very simple. So basically what happens is that this is the monomer. Monomer means smallest repeating unit. So what will happen? You just have to remove this double bond and open it both the ways. Like this. Okay, I'll just mark it, this blue double bond. Think it like this, that we have opened it in two ways, here and here. Like this is the bond, open it two ways. Okay, so you will get the minimum smallest repeating unit in a polymer. Okay, so this was the monomer. So let's look at the answer. Answer will be again C part. C double bond C. One has CH3 group. They have expanded CH3. Another carbon has C double bond OH group. Okay, answer is C part. Okay, next. Again, we have the question of which structure represents a protein. For students having 0620, 0654 course, proteins, condensation polymer is very important. I'll just give you a quick recap of how protein is formed, what is condensation polymerization. Okay, so let's look. Right. So we have two monomers in this. One is dicarboxylic acid. Di means two, carboxylic acid. 2 units of this. This one box represent some amount of carbon, some number of carbons present in between. Okay. This gets bonded with diamine. Diamine is NH2 and again NH. Okay. In condensation polymers, two monomers combine and they also release one small molecule. Here that one small molecule is water, H2O. So you can clearly see this is H2O, H2, two H atoms and one oxygen. This is replaced. Okay. Since one OH has been removed from right hand side, from left hand side also one OH will be removed. Okay. One hydrogen is removed from this segment. From this segment also, this part also one H will be removed. Okay, basically like in the right side there is diamine. Here also there will be diamine with which it will go like this. Okay, here also C double bond OH will be there. Water will be removed like this. Okay, it will keep on going and it will form a long chain polymer. Okay. So we'll just write, always write from left to right. Okay. So this is the carbon, the green one, C double bond O. Then you have a box, C double bond. Then this is all removed. Then you have nitrogen, hydrogen. Then a box, then nitrogen, hydrogen, and then this keeps on going. Okay. This bond, C double bond O, NH bond is called your amide linkage. When there are multiple amide linkages, then it becomes peptide, and many peptide linkages form protein. Okay, so we have to look for this in the option. So obviously this does not have any nitrogen. No, no. Between A and D, if you look carefully, one box is attached with either two C double bond O groups or either two NH groups. So answer will be D part and not A, because in A one box is joined with C double bond O and N. This is not possible, right? So answer will be D option. Okay. So in this video, I have covered esters, I have covered condensation polymers, addition polymers, and catalytic cracking, fractional distillation. Comment down below if you have some more requests or is there any topic which you want to study for IGCSE exams. All the very best. I'll see you in another video. Bye.